Let's solve question number 8. In an electricity experiment, a potential difference of 10 plus or minus 1 volts is applied to a piece of wire and a current of 5.0 plus or minus 0.5 amps flows. What will be the experimental value of the resistance of the wire? A, B, C, and D. As you are looking at this question, ask yourself, what experiment is it coming from? From electricity experiment. In electricity, we were told about Ohm's law, that it stated that V is equal to IR. V is voltage or potential difference. I is current and R is effective resistance of the resistors given to us. From here, what we have that R is equal to V over I. Now the option is in one decimal place. What is the what? V. Look at the V given to you, the potential difference, and look at the I. We will be saying 10 over 5 equals to 2.0 watts ohms. Can you see? Now, we have gotten the effective resistance of the resistors. Okay? We want to get the error. What is the value of the error encountered while getting this effective resistance of this resistor? R. Now, that is what you are seeing in these options, plus or minus. That means the error. To get it, ask yourself, this arrow means V raised to power 1, I coming up, I raised to power of minus 1. Now, because this I is having negative, we will use this to find the what? The error in the effective resistance of the resistor. We'll call this standard error of what? Getting effective resistance of the resistor. And this is equals to, you say the R gotten times square root of, what is the power of this? 1 times, what is the error? 1 all over, what is the voltage itself? 10. We'll square it. Plus, we'll come to this minus 1 times this one 0.5 all over what? 5. Look at it, the 5. We'll square it. So when we compute this, we'll be getting the error, the standard error of getting what? Effective resistance of the resistor. Now, this gave us 2 times square root of, this divide this 0.1 watts squared plus minus 0.1 watts squared, because this cancel this 0.1. You use your calculator, square root of bracket 0.1 squared plus bracket minus 0.1 squared. It will be giving us 0.14142. Okay? But the options are in what? One decimal place. 2 times this times 2. That will be giving us 0.2828 ohms. See, look at the error we encountered in getting the effective resistance of the resistor. Okay? Now, this is in one decimal place, approximated to what? 0.3 watts ohms. Therefore, our effective resistance is equal to the 2.0 plus or minus 0.3 watts ohms. That is it. That means we'll be looking at the option. None of the option gave us the exact value, but this is the exact value you are meant to get. Please don't just get this and say 0.1 is the answer in one decimal place. No, you must multiply it to the resistor itself or the effective resistance itself. You must multiply it to the effective resistance we got itself. Remember, in the first videos we discussed on focal length, we say focal length times what we got to get the error in focal length. The focal length times the what we wrote here. Something about here, I've forgotten the figures, but we've discussed it. We don't just discuss this and say that is the error. No, you multiply with F to get the exact. That one we got 20 plus or minus 4 cm. That is what I mean. The one we got this to be the answer. Okay? Yes. But this, you have to also do it that same way. You don't just do this and say the answer is 0.1. No, you compute it. But looking at this option, based on this is the answer, in exam, they have to solve this word to tell you that this is the answer. But if you are having this, the closest answer that will sort out this is option B. 0.2, 0.3 minus 0.1 is 0.2. 0.4 minus 0.3 is 0.1. So 0.3 is closest to 0.4 than 0.1. So we'll be taking this to be the answer. We are taking this to be the answer in the sense of that this is closest to this. Not that this is the exact answer. Look at the exact answer here in case you want to see how it is being solved. Let's go to question number 9.